Good morning, students. In the last class, we discussed about the nomenclature of the organic compounds. We studied the certain rules that govern the nomenclature of organic compounds, especially hydrocarbons. We discussed about and we learnt about the root word that indicated the number of carbon atoms in the longest possible chain. And now we are left with the very important thing, that is prefix, that is suffix. Primary, suffix. Now it's a very important thing concerned with the nomenclature. We know that we are studying the organic compounds. We are studying the compounds of carbon. Carbon has a very important ability, the ability of self-linkage. So this primary suffix, it simply indicates the linkage between the carbon atoms. Carbon generally forms covalent bonds. It may form a single covalent bond, a single sigma covalent bond. It can form two covalent bonds, means a double bond, one sigma covalent bond and one pi covalent bond. It may also form three covalent bonds, one sigma covalent bond and two pi covalent bonds. So simply the thing is that primary suffix, it simply indicates the linkage between the carbon atoms. Now there is a very simple story. It goes like this. If there is a carbon-carbon single bond, if an organic compound, if the hydrocarbon only contains carbon-carbon single bond linkages, means there are only sigma bonds between the carbon atoms, then we use the primary suffix ane. Very simple. After root word, in the last class, I gave you a brief representation of an IUPAC name. We start with a prefix. After prefix, we write root word or simply word root. After root word, we write primary suffix. And after primary suffix, we write secondary suffix. Now, we are done with the root word that indicated the number of carbon atoms in the longest possible chain. Now, there is primary suffix. Primary suffix simply indicates the linkage between the carbon atoms. If there are only single bond linkages, then we use the primary suffix ane. Now, if there is at least one double bond linkage, one or more than one, then we use the primary suffix. For carbon-carbon double bond, we use the primary suffix ene. Very simple. For carbon-carbon single bond linkage, we use the primary suffix ane. And for carbon-carbon double bond linkage, we use the primary suffix ene. And for carbon-carbon triple bond, we use the primary suffix yne. So, the rule is very simple. Single bond, only carbon-carbon single bonds, we use ane. At least one double bond or more than one double bonds, we use ene. There is a further addition of one rule. If there are more than 2, 3, 4 double bonds, what to do? But here, for double bond, we use ene. For triple bond, we use yne. So this was primary suffix. Now the most important thing is secondary suffix. Secondary suffix is the most important of all of these. Secondary suffix, it indicates the functional group present in a molecule. We know that there are diverse number of organic compounds ranging from alcohols, aldehydes, ketones, carboxylic acids, acid amides, anhydrides, esters, ethers, thiols, thioethers, acid chlorides, acid iodides, acid bromides. Indeed, we have certain other class of functional groups. So, in order to represent a functional group in a compound, we use this secondary suffix. So, the story goes like this. The secondary suffix, it simply indicates the nature of the functional group, the type of the functional group present in an organic compound. What is a functional group? Functional group can be a single atom, like oxygen, like sulfur, or it can be a group of atoms, like OH, like COOH. It can be CHO, it can be C double bond O. So, what is a functional group? It can be a single atom. Functional group is a single atom or a group of atoms that determine the physical and chemical properties of a compound. So all the physical and chemical properties of a compound is governed by a single atom or a group of atoms present in a molecule that is known as functional group. Functional group. Students, this is very, very important. What is a functional group? It is an atom or a group of atoms that entirely determine the physical and chemical properties of a molecule. There are diverse number of functional groups. But students, in your class 10th, you have to study about 3-4, I can say, major functional groups. I may be jotting down all these functional groups on the board and you pen down them. Number 1, students, the most important functional group in class 10th is the hydroxyl group. HY, DROXYL, hydroxyl group. Hydroxyl group. This is hydroxyl group is OH group. Very, very important. OH group. It is hydroxyl group. Now, the compounds that contain hydroxyl group as the functional group, these compounds are known as alcohols. Alcohols. So what are the alcohols? Alcohols are the hydroxy derivatives of hydrocarbons. Or I can simply say the compounds that contain hydroxyl group as the principal functional group. These compounds are known as alcohols. For compounds containing this hydroxyl group, we use the secondary suffix. We use the secondary suffix OL-ol. Very, very simple, OL-ol. You might have heard about ethanol, propanol, butanol, hexanol, pentanol. So all is something in an organic compound. That something is actually an hydroxyl group indicated by secondary suffix OL-ol. Then another, I can say, functional group. We have this compound, that is, I will be discussing here only those compounds, only those functional groups that are in your syllabus. Number 1 is alcohols, and number 2, the very, very important, this C double bond O. C double bond O. Students, look at this group of atom, C double bond O. This group is known as carbonyl group. Carbonyl group. And this carbonyl group, it gives rise to many, many functional groups. Now listen, students, if we have a carbonyl group, that is C double bond OH, C double bond O, carbonyl group. Listen, students, this C double bond O, it is a carbonyl group. So if carbonyl group has one hydrogen, if carbonyl group, it has a carbonyl carbon and an oxygen. If the carbon of the carbonyl group has at least one hydrogen. At least one hydrogen means this CHO group. So this group becomes CHO group. This group is known as formyl group. Formyl group. Now listen, this formyl group is a functional group. Now all the compounds that contain formyl group as the principal functional group, that contain CHO group in their structure, such compounds are known as aldehydes. Aldehydes. CHO group, formyl group, a functional group, if present in a molecule, such molecules are known as aldehydes. So for aldehydes, for compounds containing the CHO group, we use the secondary suffix AL. For alcohols, we were using OL. And for aldehydes, we use the secondary suffix AL. You might have heard about ethanol, butanol, propanol. Means whenever in your mind, whenever you hear a word al means that compound has the functional group aldehyde, formyl group, CHO group in its structure. So the secondary suffix for aldehydes is AL. Functional group is formyl group. Now we have third one. Again I am repeating, I will be discussing here only those functional groups that are in the class 10th. Now, if this students again C double bond O, this group is known as carbonyl group. If carbonyl group is attached with R means alkyl chains, carbon chains on the either sides, means there is no hydrogen on either side. If there are only alkyl groups attached to the carbonyl carbon, such compounds are known as ketones. They are known as ketones, or sometimes they are known as oxonones, or simply ketones. So ketones have the functional group that's known as the C double bond O group, oxo group, or simply keto group. Compounds that contain ketonic group, that contain this oxo group, or in a very, very simple language, if the carbonyl group is attached on either sides by the carbon chain, by simply alkyl groups, sometimes aryl groups also, such compounds are known as ketones. And these ketones, for these ketones we use the secondary suffix. For this ketonic functional group we use the secondary suffix -on. This secondary suffix -on. You might have heard about propanone, butanone. These are simply ketones. Now, of shifting from ketones, we have another example of classical organic compounds. We have the compounds. Listen students, if we have the functional group, this C double bond O, again this carbonyl group, if it has now OH group, carbonyl group in addition with OH group, or simply this group COOH group. This group is known as carboxylic group, carboxylate group, or carboxylic group. If the compounds containing if the compounds have carboxylic group in their structure, such compounds are known as carboxylic acids. They are known as carboxylic acids. Carboxylic acids. So, compounds that contain carboxylate group are simply containing COOH group, acidic group in their molecule. Such compounds are known as carboxylic acids. And for this carboxylic group, for these carboxylic acids, we use the secondary suffix oic acid, OIC, oic acid. Oic acid. Oic acid. Again, I am repeating oic acid. You might have heard about ethanoic acid, propanoic acid, butanoic acid. So these all compounds where we use oic acid, they have the functional group COOH in their structure that determines its physical as well as chemical properties. And last one, we have in our periodic table, we have a group. We know in periodic table there are 18 groups and there are 7 periods. Group number 17. Group number 17, halogens. Halogens, I will be writing all the halogens. We have halogens like F, fluorine. We have Cl, chlorine. We have Br, bromine. We have I, iodine, and we have astatine. Astatine is radioactive, so I will be excluding the astatine. So, in certain cases, we have a single atom, this halogen, in the form of fluorine, chlorine, bromine, or iodine, present in the molecule that entirely determines its physical and chemical properties. Such compounds are known as halogen derivatives. Like we have fluoro derivatives, we have chloro derivatives, we have bromo derivatives, and we have iodide derivatives. Now there is a very important thing. You know, this fluorine, chlorine, bromine or iodine, if present in a molecule, they are written not in secondary suffix, they are written before the root word. Written before the root word in the form of, like, simply for halogens we write halo, means for fluorine we will be writing fluoro, for chlorine we will be writing chloro, for bromine we will be writing bromo, and for iodine it's very obvious, we may be writing iodo. So these were the 3 classical examples of, I can say, these compounds that we were discussing, that we were supposed to discuss in this chapter. So I will be reminding, I will be recapitulating. Number 1, we are supposed to discuss, number 1, alcohols, OH, functional group, and the secondary suffix OLol. Number 2, aldehydes, functional group, formyl group, CHO group, secondary suffix ALL. Number 3, carboxylic acids, functional group, carboxylate group, COH group, secondary suffix oic acid. And then for halogen derivatives, we write in prefix halo, I can say chloro, fluoro, bromo, iodo, so on and so forth. So this was about primary suffix, this was about secondary suffix and primary suffix. Now, all the things are clear. Root word is clear, primary suffix is clear, and secondary suffix is clear. Now what is prefix? Simply the word indicates prefix, something that fixes initially to root word. Now what is prefix? So this prefix, we will be discussing it in the next session, because in order to discuss prefix, I have to first of all say you what is a side chain. what are substituents. So we will be taking it in these rules. So now the topic will be, we will be shifting on the second tier of the nomenclature. What is that second tier? That is rules of the nomenclature. Because already stated in the earlier topic, I said that what is nomenclature? The science of naming the organic compounds based on its structure, that we discussed in this prefix, root word, primary suffix, secondary suffix, and certain framed rules. These rules are framed by International Union of Pure and Applied Chemistry. What are these rules? Students, let us discuss these rules. Rules of nomenclature. Now, we will be discussing the rules of nomenclature. Rules of nomenclature. Rules of nomenclature. Very simple. Rules of nomenclature. The first rule. The first rule goes like this. Number one rule, selection of the longest possible chain. So the first rule is selection of longest chain. Selection of longest chain. We are discussing the nomenclature of hydrocarbons. So this rule states that we have to select the longest possible continuous carbon chain present in the molecule. You know, earlier I had stated that carbon has the unique property of catenation, self-linkage. It forms long carbon chains. They may be linear, they may be branched, they may be cyclic. So, if we people are supposed to name an organic compound that contains long carbon chains, the first rule goes like this. You have to select the longest possible continuous carbon chain. That longest possible continuous carbon chain is known as principal chain. Principal chain. First name. It is also known as, principal chain is also known as, it's known as parent chain. Second name, parent chain. Or it's also known as main chain. Main chain. And the chains, and the carbon chains that are not included in the parent chain, or I can say like this, the carbon chains that are excluded from the longest possible parent chain, those chains are known as side chains. Side chains are simply, they are known as substituents. Substituents. I will be clearing this concept with a very, very simple example. Let me show you the simple example. Students, I have a very, very simple rule for you. I have a very, very simple idea that I will be sharing with you. How to select the longest chain. For selection of the longest chain, students, you remind a term long drive. You remind a term long drive. Go for the long drive. Now you'll be saying, but sir, what is long drive? I will be here writing a structure of a carbon compound. CH3. This is CH3. This is CH2. This is CH. This is CH3. This is CH2. This is CH2. And here we have CH3. Suppose this is a hydrocarbon, because we have hydrogens and carbons. Now the first question that strikes our mind is that, sir, why have you given this carbon 3 hydrogens, this carbon only 2, this carbon none of the hydrogen, and this carbon 1? The answer of this simple story is the tetravalency of carbon. Carbon forms 4 covalent bonds. In this carbon, also known as primary carbon, it's only linked with only one carbon atom. So it only has one covalent bond. So it needs 3 extra covalent bonds to satisfy its tetravalent nature. So it is given with 3 hydrogens. This carbon, I am talking about this carbon or this carbon, students. This carbon has 2 covalent bonds. In order to satisfy its tetravalent nature, I am giving him 2 extra hydrogens, 4 valency satisfied. And this carbon, it's known as tertiary carbon. This is tertiary carbon, this carbon, students. This carbon is linked with 3 other carbon atoms with 3 covalent bonds. It only needs one covalent bond that's satisfied by this hydrogen. This is your tertiary carbon. And talking about this carbon, it's known as quaternary carbon. It has already 4 bonds. It doesn't need another external, extra hydrogen atom. So I'm not giving him the hydrogen. Is it clear to you? Now let's shift towards the rule. I have to select the longest possible chain. Students, let's go for the long drive. If I will be starting with this carbon, it's only the root of one carbon. It's only the root of one carbon. But look at the students, this carbon. So this root has maximum number of carbon atoms. So you can go for a long drive. Starting from here, now here I have 3 options. I can go downwards, but it is not the longest way. I can go left side, but it is not the longest way. So I have to obey the longest chain. So I will be going straight. Here I have 2 options, either downwards or straight. But the straight one is the longest possible chain, is the path of maximum length. So this will be your longest chain. This is the longest possible chain of the compound. This chain enclosed in these dimensions, it's known as the longest possible chain. It's known as the parent chain that I discussed earlier. It is also known as principal chain, or it's also known as main chain. Now, students, look at this. These carbon chains, this carbon chain, they are not included in the parent chain. So these chains are known as side chains. Sometimes they can be more than 2, more than 3. Depends upon the molecule, structure of the molecule. So these are side chains. This is a side chain. This is a side chain. Or simply they are known as substituents. And now this was the selection of the longest chain. I will be drawing now. I will be giving you another example, a very, very big example that may clear all your confusions and all your queries. I will be drawing a very, very complex molecule. But now you people are supposed to choose the longest possible chain. Students, listen. Suppose this is CH3. Now this compound is CH2. This is CH2. This is CH3. This is CH2 and this is CH3. this is CH2, this is CH, this is CH2, this is CH3. This is CH, this is CH3, this is CH2, this is CH, this is CH2, this is CH2, this is CH3, this is CH3, this is CH2, and this is CH3. Now, suppose this is an organic compound. Now, in this organic compound, you have to select the longest possible chain. So, you will be reminding the simple trick we have to go for the long drive. Let's start, students. This is a carbon number 1, the root of only 1 carbon, root of only 2 carbons. This is the root of 1, 2, 3 carbons. So I will be starting from this point, going upwards, then longest possible way, I'll be going like this. This is 1, 2 carbon, there are more carbons, I'll be going straight, then downwards. Now here, this is the root of only 1 carbon, but this is the root of 1 and 2 carbons, so I'll be going like this. So this becomes the longest possible carbon chain. This becomes the longest possible carbon chain, known as principal chain or parent chain. And rest of these chains, they are known as side chains. Now students, I told you in the earlier topic that prefix, these side chains, they are written in prefix, while as the root word, the magnitude of carbon atoms, the number of carbon atoms present in the parent chain, it's written in root word. These are written in as prefix. There is an additional rule. We generally use YL for these substituents. Alkyl. For methane, we replace ANE by YL, means methyl. For ethane, we replace ANE by YL, means ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl, dodecyl, so on and so forth. So this was the selection of the longest chain. Now the second rule. Now we have selected the longest possible chain. Now we will be looking for the numbering the carbon chain. So there are two ways. Either I have to number this chain from this direction, or I have to number from this direction. So the numbering of the carbon chain, it is an important aspect in the nomenclature. For numbering the carbon chain, we use the second rule of the nomenclature. That very rule is selection of the longest chain. After that comes I will be writing the rule, lowest set of locants rule. There are actually two rules, lowest set rule and lowest sum rule. But the lowest set rule is the universal rule applicable for all compounds. So we will be using only one rule, that is lowest set rule of locants. So write down second rule. Lowest set of locants rule. Now lowest set of locants rule. Now what is a locant? Already I stated that the principal chain or the main chain, it can be numbered either in this direction or in that direction. Now there are two types of carbons. Listen, suppose I have this chain CH3, this is C, this is CH3, this is CH, this is CH2, this is CH, this is CH2, this is CH3. Suppose this is CH2 and this is CH3. Suppose this is an hydrocarbon, an organic compound. The longest chain is simply this one is the longest possible chain. Now, either I will number it from this side or this side. Listen students, this carbon is not a substituted carbon because it do not have any side chains. So the carbon that has side chains on it, that is linked with other carbon atom via side chain, not the continuous chain, via these side chains. These carbons are known as substituted carbons because substituted carbons have a substituent on them. Now, I will be suppose numbering this carbon chain 1, 2, this carbon is 3, this carbon is 4, this is 5 and this is 6. Very, very important term. What is a locant? Locant, location. So, the number indicated on the substituted carbon is known as the locant. So, what is the locant of this carbon? 2. What is the locant? This is substituted carbon. The number on the substituted carbon is its locant. So, locant is 4. I can't say these are locants because they are not substituted carbons. They do not have the, I can say, side chain or substituent on them. So, now what is the locant? The number indicated on the substituted carbon is known as locant. Now I have the two ways. Either I have to number it from this side or I have to number it from this side. So I will be using which rule? Lowest set of locant rule. What does this rule says? What is the story of this rule? Very simple. What I will be doing, I will be numbering this chain from this side. 1, this is 2, this is 3, this is 4, this is 5 and this is 6. Now I will be making a set of these locants in this direction. So the set of locants will be 2, comma, then I have 4, I will be writing 4, and 2 and 4, only 2 and 4. Now, I will be numbering this longest possible parent chain on this side. So it will be starting 1 from this side. 1, 2, this is 3, this is 4, and this is 5, and this is 6. Now again, form this set of locants. If you number this carbon chain from this side, this set of locants, it will be simply now 3 and 3 and it will be 5. So 3 comma 5. 3 comma 5. Now what I have to do? This is the set of locants when I was numbering the chain from this side, from left side. This is the set of locants when I was numbering the chain from this side. Now what I am supposed to do is simply I will compare the locants one upon one. Here I have the 2, here I have the locant 3. Now the locant where you get the first point of difference means where you have two different locants. Here I have 2, here I have 3. Means it becomes the first point of difference. Now the set that has lowest value of the locant is preferred for the numbering. So this set has the lowest locant 2. This has 3, so it has lowest locant. So I have to prefer this set. What does that mean? I have to number this chain from this side. Very simple. So this rule is known as lowest set of locant rule. In some cases, you might get a very complex data. You might be having same locants 2, 2, then 3, 3, then 4, 4. The moment you get the first point of difference, then at that very point, you will be comparing the two locants. The set that has the lowest value of locant will be preferred for the numbering. I will be citing this with another example. with another example. It may take me 2 minutes, only 1 minute to clarify this example. Listen, students, I have this compound CH3, this is CH, this is CH3, this is CH2, this is CH, this is CH3. Suppose this CH2, it's CH3. Now it's CH, it is CH3, and this is CH2, CH3. And I have this compound CH2, this is CH3, and this is CH3. Suppose I have this compound. First of all, I have to select the longest possible chain. I'll be going from this. Then here I have a very simple way. I'll be going this. Then 1, 2. And we have here 1, 2. So I will be going like this. This is the longest possible chain. Suppose this is the longest possible chain. Now I have to number the chain. Either I am supposed to number this chain from this side or from this side. I will be using the lowest set rule. Now I will be making one set. This is carbon 1, suppose. This is locant 2, substituted carbon. This is 3. This is locant 4, substituted carbon. This is locant 5, two substituents. Here I may omit this hydrogen. And this is 6, substituted carbon, locant. This is 7. Now I will be making this set of locants if I am numbering this carbon chain from this direction. So the set will be locant 2, only substituted carbon, 4 locant, and then 5. Here we have a different story. We have 2 substituents on this carbon. So I will be writing 5 twice. That's like this, 5, 5. Why 2 times, students? Because I have 2 substituents. That's why 5, 5. Now, this is the set of locants. If I am numbering the carbon chain from this side, now I will be numbering this chain from this side. So it will be carbon number 1. It will be locant 2 now. It will be locant 3 now. It will be locant 4 now. It will be locant 5. Sorry, no locant. This is 5. It will be locant 6. And we have carbon 7. Again, I will be making this set of locants from this side. It will be firstly 2. Then after 2, I will be having 3 now. But 3 twice. Because I have 2 substituents. 3, 3. Then I will be writing here 4. And after 4, I will be writing 6. Now listen. 2 sets of locants. These sets will tell me, they will give me an idea how to number a carbon chain. Now I will be comparing these locants 1 upon 1. Here we have 2, here we have 2. Means first point of difference. I am not getting here the first point of difference. Now I will be shifting to second locant. I have here 4 and I have here 3. The lowest value is this 3. So this set, it gets a priority. The lowest value of the carbon, the lowest value of the locant gives you the priority in the lowest set rule. So this set will be selected. That means this carbon chain will be preferred for the numbering. So again, you will be taking many examples. In that very, I can say in all those examples, you will be using the lowest set rule. But there is another rule, lowest sum rule. In lowest sum rule, we simply add these locants in this group and in this group. We get the same result. The result given by the set rule is also given by the sum rule. But in certain cases, sum rule and set rule, they run in anti-parallel direction. And at that very time, we use the set rule. That's why set rule is the universal rule. And we will be using this set rule in this nomenclature. In the next class, we will be continuing the nomenclature of organic compounds. Thanks, students.